Assalamu alaikum students. This is Engineer Zishan Akbar from Civil Engineering Excellence Academy. Today I am going to teach you the basics of civil engineering part 5. Before starting my video, I would like to request all of you to please subscribe my channel and press the bell icon so you can get notifications of my newly uploaded videos. So let's start with the video. This video is the continuation of the last video, number 4, basics of civil engineering part 4. This is part 5 for basics of civil engineering, discussing the concrete as well. The first point here is the difference between stirrups and ties. Everyone has to know about the difference between stirrups and ties as a civil engineer. So first of all, I will let you know that what the stirrup is and what the ties are. The stirrups are used in beams. So keep in mind that stirrups are used in beams as transverse reinforcement. What is the purpose of these stirrups? I will let you know in the second point that what is the purpose of stirrups or ties. So uh, at this point, at this stage, keep in mind that stirrups are only used in beams. These are not used in columns as a transverse reinforcement. So the second is ties. Ties are always used in columns as transverse reinforcement. It means that ties are replacement of stirrups for columns as stirrups were in case of beams. So second, you can see from this figure, this is a beam. In this beam, you can see this is the longitudinal reinforcement, these main bars, this is the main reinforcement, and you can see this transverse reinforcement in this beam provided at some specified distances. These reinforcements are known as stirrups. In case of this column, this is a vertical member, and beams are mostly horizontal members. These vertical members are provided with transverse reinforcement. This transverse reinforcement in case of columns is known as ties. The number two is the purpose of stirrups and ties. The purpose of stirrups and ties is to keep longitudinal reinforcement in position. Simply, we can see in figure, this is longitudinal reinforcement for beam, and these are longitudinal bars for columns. So basic purpose of these ties or these stirrups is to keep these main bars at their specified position. And the second purpose is to resist shear stresses or shear forces. So these both are the main purposes for which stirrups and ties are used in columns and beams. So third point is the types of ties based on column cross section. Columns are mostly in two or three cross sections. They may be more than three cross section. They may be trapezoidal. They may be in any cross section depending upon the choice. But here I am going to discuss mostly used column cross sections, which are circular and square or rectangular. So types of ties based on column cross section is preferably, I have divided this in two types. For circular column, usually spiral ties are used. What are spiral ties? Let's see with the help of a figure. These are main reinforcements. These six bars, vertical bars, are known as main reinforcement. To keep this reinforcement at its place, we have to provide ties in columns. But in this case, you can see that these ties are continuous with the length of the column. So this type of ties are known as spiral ties. They are making spiral around the main reinforcement. In case of square or rectangular column, usually separate ties are used like stirrups in beams. What are these separate ties? These are separate ties, as you can see here. These are separate ties. And you can see here they are separate. This is separate, this is separate. There is no connection between these both ties or three ties and up to so on. The fourth point is, what is full form of CC in concrete structures? Simply the CC means center to center distance. CC means center spacing between bars or any civil engineering structural member, that may be distance between columns, beams, etc. So in this figure, you can see these are two columns or beams or as such any structure may be. This is the center of this structure or this member, and this is the structure of this member. So from this line, dashed line, to this dashed line, there is a distance. This distance is known as C/C distance. Number fifth is, what is minimum required thickness of slab in design of construction, design or construction for civil engineering? The minimum required thickness of slab is 150 millimeters or 6 inches. From figure, this is the length of slab, this is the width of slab, and this is the thickness of slab. The minimum required thickness H minimum is equal to 150 millimeters or 6 inches, subjected by ACI 318. Number six is, what is a simply supported beam? This is very simple question which may be asked by any civil engineering. What is a simply supported beam? A simply supported beam is a beam having pin support at its one end and roller support at its other end. So simply you can see by in this figure that this is a beam, a horizontal member. At this end it has a pin support, and at this end it has a roller support. It means a beam is having two supports at its two ends. One end is supported on a pin and other end is supported on a roller. So you can see there is no continuous portion or any other portion. This beam is supported at two ends, and one is pin, other is roller. So simply this is a simply supported beam. Number seven question is cantilever beam. What is a cantilever beam? A cantilever beam is a beam having fixed support at its one end and other end is free. You can simply see from figure that this end of the beam is fixed while the other end is in air or it is free. So this beam will be known as cantilever beam. The number eight is, what is an overhanging beam? The overhanging beam is a beam having one part as simply supported and other parts are in air. It means that a beam having one part as simply supported, it means that it will have a support, a pin support, and a roller support midway or at one end, but other end will be in air. So simply we can see this is a roller support, this is a roller support, this part or this span of the beam is in air, and also this part of the beam is in air. So this is doubly overhanging beam. It is overhanging from two sides. Simply, if this was going to be overhanged in first in one direction, then this was simply an overhanging beam. Number nine is a fixed beam. As the name suggests, that a fixed beam is a beam having both supports at its ends as fixed supports. A beam which is fixed means having fixed support at both ends, at it is known as fixed beam. So you can see here it is a beam, it has two ends. Suppose this is one end, this is second end, and at this end there is a fixed support, and at this end there is also a fixed support. So this is known as a fixed beam or a fixed ended beam. So number 10 is a continuous beam. What is a continuous beam? The name clarifies the concept of a continuous beam, a beam which is continuous over two or more spans. Continuous means there is no break in beam, but there are supports at specific interval. You can see in the figure that from this point there is a pin, at second interval there is a support, at third there is a also a roller support, and at fourth point there is also a roller support. So this beam has totally three spans: span number 1, span number 2, and span number 3. So this beam is known as a continuous beam because it has more than two spans. Or simply, if it was going to be like till here, then this would have also been a continuous beam. It has three continuous spans, so it is still a continuous beam. So point number 11 is the dead load of a structural member. What do you mean by the load for a structural member? Mostly the dead load of a structural member is the self weight of the structural member. You have to calculate the self weight of the structural member, and you will get the dead load for that member. Number point is, what should be the qualities of water to be used in construction? Simply, the first and the most important criteria for water to be used in construction is that it should be, if you can drink it, then you can use it in construction. It means that water should be drinkable, aesthetically pleasant, and its pH value should be minimum 6. It means that minimum value pH value for water is 6 to be used in construction industry. You cannot use any type of water whose pH is less than 6. uh, Means you can use the water which has a pH value between 6 and 7, or you can say that it must be near to 6 but not less than 6. Number 13 is height of a floor in a building. What will be the height of a single story or one story in a building? That is 3 meter normally. This is normally, but not a hard and fast rule. This is a thumb rule. 3 meter, the height of a floor in a building is normally 3 meter or 10 feet. So number 14 is length of a steel bar from factory. Whenever you uh, get a steel bar prepared or manufactured from a factory, then its length will be 12 meters or 40 feet. This is the standard length from factory of a steel bar of any dia. Lapping condition for steel bars. What are the lapping conditions for main steel bars? The simply, we will not provide lapping if the diameter of the bar is greater than 36 millimeter. So simply you can read this statement: lapping of bars is not done if diameter of main bar is more than 36 millimeter. It means that if the diameter is of the bar is less than 36 millimeter, then simply lapping can be provided. But if diameter of the bar is greater than 36 millimeter, then lapping cannot be provided in this case. So these are the 15 points for this video. See you in the next video. Thank you very much.